Hello everyone. So today we are going to learn about the sign convention of mirrors and lens. That means spherical mirrors or spherical lens. What are the sign conventions? So you know the object, image, distance of object, distance of image. For this sign convention is required. Okay, we can take the object distance as u, image distance as v, and focal length as f. Okay, these three are the distances which we have to find out for a particular situation. So first we are going to discuss about the sign convention of mirrors. Okay, mirrors are of two types, you know, concave, that means spherical mirror, concave and convex. So sign convention, it is the same as coordinate geometry. Coordinate geometry means same as this plan, Cartesian plan. This is x-axis, this is y-axis. So towards the right side, okay, towards the right side it is positive, towards the left it is negative, in the upward direction it is positive, in the downward direction it is negative. So if you compare this with the mirrors, suppose say this is concave mirror and this is convex mirror. These are principal axis. Okay. Now this mirror you can compare as the y-axis, and the principal axis you can compare as the x-axis. Okay. Now the distance towards the left of the mirror are negative. Why? Towards the left they are negative. Towards the right of the mirror, the distances are positive. So first thing, for concave mirror or for convex mirror, the object is always placed at the left side. Clear? The object is always placed at the left side. Now, for mirrors, if the mirror forms images, you know images are of two types, real and virtual image. So basically the concave mirror can form virtual and real and virtual both the images, and the convex mirror can form only the virtual image. Now you should know that what is the sign convention for image. Okay, for real image, see real image is always formed towards the left side. So this is concave mirror, object is there, image is also produced towards the left side. That is for real image. So for real image, since it is in the left side, that's why phi is negative. Why? Since while coming to the left, the phi is negative. If in case of virtual image, the image is always placed at the right side, towards this side. Okay, towards the right side, the virtual image is formed, so that phi is always positive. Clear? So images are of two types, real and virtual. For real image, phi is negative. For virtual image, phi is positive. Or conversely, you can say, if you find phi is negative, then the image is real. If phi is positive, then the image is virtual. Now, what about the object distance? U. Object distance, that is U. U is always negative. Why U is negative? Because the object is always placed towards the left of the mirror, towards this side, or in case of convex also towards this side. So image is always formed towards left of the mirror. That's why it is always negative. Okay, now phi, sometimes it can be negative, sometimes it can be positive. It depends on the nature of the images. Clear? Then you should know the nature of nature of mirrors. Mirrors are of two types, spherical mirrors, concave and convex. So how will you identify that a mirror is concave or convex? If some values are given, values means object distance, image distance, focal length are given. So you know, for the concave mirror, focus is always placed towards left side. That is focus. In case of convex, focus is placed always towards right side. So if the focus is always placed towards the left in case of concave mirror, so this distance is negative and this distance is positive. That means for concave mirror, f is always negative. For convex mirror, f is always positive. Clear? Now, by observing the values, you can also conclude that the mirror is concave or convex. If f is negative, that is focal length is negative, the mirror is concave. If the focal length is positive, the mirror is convex. Okay, clear? Now, again I repeat that u, object distance is always negative for both the concave or convex mirror. Then for real image, phi is negative, phi means image distance. For virtual image, phi is positive. Again, if f is negative, that is focal length, the mirror is concave. If f is positive, the mirror is convex. Clear? Now, we will observe about the lenses. So, lenses are of two types. What are the two types? It may be convex or it may be concave. Okay, this is convex and this is concave mirror. So same, you can compare this with the plan, that is coordinate geometry, Cartesian plan. So this lens or the convex lens or concave lens, this can you compare with the y-axis, and the principal axis you can compare with the x-axis. Now, convex lens or concave lens, both may form real or virtual images. So images are of two types, real and virtual. Clear? You know that convex lens can produce both real and virtual images, and the concave lens can produce only virtual images. Clear? So for real image, so here also in case of lens also u is always negative. Okay, in case of lens also u is always negative. Why? Because object is always placed towards left side. Object is always placed towards left side. Clear? And image, if the image is real, you know real image is always formed towards the right side of the lens. Okay, towards the right side. That's why in case of real image, phi is always positive. In case of virtual image, phi is always negative, because in case of concave lens or in case of convex lens, virtual image is formed towards left side. Clear? So image are of two types, real, virtual. For real, phi positive. For virtual, phi negative. It is totally opposite to the formation of mirror. Okay, now you should know the nature of lenses. Lenses are of two types, convex and concave. Clear? Convex and concave. So for convex lens, how will you identify? You can identify the convex lens by focal length. Now for convex lens, the focus is towards right, this is focus. And for concave lens, the focus from which the rays are diverging now, that is present towards the left side. So for convex lens, the focal length is positive, and for concave lens, focal length is negative. Why negative? Because it always produces towards the left. Now the problem is only by observing the focal length you cannot say the image is real or virtual, or only observing the image you cannot say the lens is convex or concave, because in case of convex lens both real and virtual image can be formed. So to identify the image you have to observe the distance of image, and to identify the lens you have to observe the distance of focus, that is focal length. Clear? So again I repeat that object distance is always negative in case of both the lenses. Why? Because object is always placed towards left. Images are of two types, for real phi positive, virtual phi negative. For lens convex or concave, for convex f positive, for concave f negative. Done? So this is the sign convention actually. Now along with the sign convention, you should know the formula for magnification also. Okay, what do you mean by magnification? Actually magnification you can find, it is called as M, you can find by this formula H2 by H1. What is H2? This is the size of image, or you can say height of image. H1 is size of object, That is actually height of object. Clear? Now, magnification basically refers in this term that the image is how much greater or smaller than the object. The ratio means you will find an answer there. It means that it explains that how much the image is greater or smaller as compared to the object. That is actually magnification. Okay? Now, if you find the value of magnification is greater than 1, okay, greater than 1. Greater than 1 means this should be greater than this. The numerator should be greater than the denominator. If numerator is greater than the denominator, the fraction is improper fraction. In that case, it is greater than 1. So if it is greater, it means that image is greater than object. That is size. And if magnification is less than 1, in that case image is smaller than the object or less than the object. Why? Because if m is less than 1, it should be greater, it should be smaller. So if it is greater, the ratio will be less than 1. Clear? Now, you should know the magnification sign convention for magnification. For mirrors or for lens, both the same formula is used for the both mirrors and lenses. Okay, now here m is equal to h2 by h1. Here m is equal to h2 by h1. Same formula. So for mirrors, real and virtual image can be formed. And for lens also, real and virtual image can be formed. Now, for real image, what is the magnification for mirror? Now see, this is the size of the object. You know that object is always placed on the principal axis. Yes, on the principal axis means what? It is always positive. For real image, h1 is positive. And for virtual image also, h1 is positive. It is also same in the case of lenses. h1 is positive. Here also h1 is positive. Done. Now you have to observe h2. h2 is the image size, that is height of the image for real image. You know, for mirror, so suppose this is concave mirror. If the real image is formed, it is always below the principal axis. If it is below the principal axis in case of real image, then h2 is negative because direction is towards to downward direction. Now for virtual image, you know that for virtual image the image is always produced above the principal axis. If it is above the principal axis, then h2 is also positive. So for mirror, for real image, magnification is, this is minus negative by positive, so magnification is also negative. So you can find also by this method, h2 is negative, h1 is positive, ultimately minus plus, this is negative. For virtual image, magnification is both are positive. So plus plus, actually it is positive. Okay, for mirror, for real image magnification negative, for virtual image magnification positive. Now coming to the lens. For lenses, you know, same real image object height is always positive. Why? It is always kept above the principal axis. The image height in case of real image, it is also negative. Okay, and for virtual image, the image height is always positive. So for lens also, if it is convex lens, if the object is here, then the image will form here in case of real image. Done. And in case of virtual image, the object image will form in this region. So that for real image, h1 positive, h2 negative, virtual both are positive. So in that case, for real image, magnification is plus minus ultimately minus, and for this plus plus ultimately plus. So magnification is same for mirror and lens. For mirror, real image, magnification negative. For lens, real image, magnification negative. For mirror, virtual image, magnification positive. For lens, virtual image, magnification positive. Okay. Okay, this is the sign convention. Also, you can find the magnification by this formula. For mirror, m is equal to minus v by u, that is distance of image and objects. And for lens, this is for mirror. And for lens, m is plus v by u. Okay, so for mirror you can write h2 by h1 is equal minus v by u also, and for lens h2 by h1 is plus v by u. So by using both the formulas you can find the magnification. Okay, so this is the sign convention and the formula of magnification for the chapter light, refraction and refraction for class 10. Okay, I think this is clear to you. If you have any doubts, then comment me. By comment, you can ask me questions if you are not understanding the topic. In the next video, again, I will start this topic, and after this topic, I will start the numericals. That means, along with this sign convention, how the distance of image and objects can be measured. Okay, and also the refraction of rays for the different positions of objects. Okay, I hope you understand this. So thank you for today and have a good day.